Welcome back. We're looking at graphing rational functions. In our last video, we looked at domain restrictions and how they appeared in our graphs of our functions as vertical asymptotes or holes. In this video, we are going to look at horizontal asymptotes and slant asymptotes and kind of what's happening as x approaches positive infinity or negative infinity. If I look at the general form of a rational function, I have a leading term of a sub n times x to the n in the numerator and a leading term of b sub m times x to the m in the denominator. And what this equation gives me, or what I see from this equation, is that I have a degree of the numerator and a degree of the denominator. When I identify those degrees, I can understand a lot about the end behavior of my graph. We have a couple rules. We're actually going to look at why these rules exist, but these are the rules. If the degree of the numerator is less than the degree of the denominator, so if the degree of the numerator, let's say we have an x term, and the degree of the denominator is bigger than that, so we've got an x squared term, as our function, as x approaches infinity or negative infinity, our y value is going to approach 0. That's going to give us a horizontal asymptote of y equals 0. If they have the same degree, like I have an x term in the numerator and an x term in the denominator as my leading terms, my horizontal asymptote is going to be a ratio of the leading coefficients. So that would be a sub n over b sub m. We will look at kind of why that ends up happening. And if the degree of my numerator is bigger than the degree of the denominator, so I have an x squared in the numerator and an x in the denominator, I'll either have no asymptote, or I will have, or no slant asymptote, or no horizontal, or I will have a slant asymptote. We'll talk about what the slant asymptote really is. But in order to look at these, we are going to kind of talk about a different way we want to write our equations. So if the general form of my equation is that I have a polynomial over a polynomial, a really awesome or helpful way of looking at these equations is if I have it as a ratio plus something else. So in this ratio, we have a couple things that must be true and that we actually do know to be true from this. Once we get to this form of the equation, and we are going to get there by factoring and canceling common terms, and then doing long or synthetic division, the degree of the numerator here will be smaller than the degree of the denominator. When that happens, as x gets bigger and bigger and bigger, the denominator is going to get bigger at a faster rate than the numerator, and this piece here will become 0. So when x gets really big positive or really big negative, this ends up being 0. So our graph is going to get closer and closer to approaching whatever is here, to that e of x. I've also got some other interesting things here, that our domain restrictions are from b of x. Once we've simplified and done division, we end up getting a new denominator, and that new denominator is going to be our vertical asymptotes. Any other domain restrictions from b of x that no longer appear are going to represent holes in our graph. And if I set this numerator equal to 0, I'll end up getting my x-intercepts, but we'll kind of look at that one a little bit later. So using this information that I've got here, we are going to identify the horizontal or slant asymptotes of a couple graphs. Now, if I look at this first graph, I have 1 over x squared minus 1. So the degree of my numerator, so n, the degree of my numerator is 0 because there is no x term, and the degree of my denominator is 2 because I have an x squared. N is smaller than m, so I am going to have a horizontal asymptote of y is equal to 0. And let's kind of think about this. Okay, so if x gets really, really big, so let's say x is 100, okay? The denominator is going to be 100 squared minus 1. So that's 9,999. If I take 1 divided by 9,999, I get 0.0001. So this denominator is going to be getting bigger and bigger and bigger. So if I take 1,000 squared minus 1, I have 999,999. So 1 over 999,999 is going to give me 0.000001. So that's a really small number. This number is getting smaller and smaller the bigger this gets. So this whole piece here is going to approach 0. If I look at this next piece, I have x minus 1 over x squared minus 3x. The degree of my numerator is 1 because I have an x term, and the degree of my denominator is 2 because I have an x squared term. So when I look at those relative degrees, again, my numerator has a smaller degree than my denominator. So my numerator smaller than my denominator. This is going to end up with a horizontal asymptote of y is equal to 0. This is a little harder to see, but if I'm looking at the ratio of my numerator and denominator, if I'm looking at a number like 100, if x is 100, my y value is going to be 100 minus 1, so that's 99, over 100 squared minus 3 times 100 minus 10. 9,690. If I go up to x is 1,000, y is equal to 1,000 minus 1, which is 999, over 1,000 squared minus 3,000 minus 10. I now have 996,990. And if I look at the ratio of these, 99 divided by 9690, that's 0.01. 999 divided by 996990 gives me 0.001. This number is getting smaller and smaller, and it's approaching 0.